Pinholes. Ugh. If you work with industrial coatings, you know exactly what I'm talking about. These tiny little defects can cause massive headaches, right? They lead to product failures, costly rework. It's a huge problem. So in this explainer, we're going to break down exactly why they happen and, way more importantly, how to stop them for good. Let's dive in.
Okay, first things first, let's get one thing straight. We are not just talking about a simple layer of paint here. A modern industrial coating is a seriously engineered functional component. It's what makes the difference between a part that just looks good and a part that actually performs under pressure.
Think about it, whether it's on a car part, an aerospace component, or some sensitive piece of electronics. That coating is the primary barrier. It's the first and last line of defense protecting that core material. And when it fails, the entire part is at risk. So yeah, the stakes are incredibly high.
And that really is the million-dollar question, isn't it? How can something so small cause such a huge disaster? Well, a pinhole isn't just a cosmetic flaw. It's a breach in the armor. It's a direct pathway for moisture, for salts, and all sorts of other corrosive stuff to get in and attack the substrate. That's what leads to that premature, catastrophic failure. So to really understand why pinholes happen, we've got to go all the way back to the beginning. The problem often starts long before that coating ever even touches a surface. It begins with the chemistry, with the complex recipe of the formulation itself.
You know, a coating formulation is a lot like a really complex chemical recipe. Every single ingredient has a very specific job to do, and they all have to work together in perfect harmony. If even one of those components is just a little bit off, the entire system can be compromised. And what's wild is just how many things can go wrong before you even open the can. Look at this. The binder, the stuff that forms the film, it might not cross-link properly, making the coating brittle. The pigments could clump together. That's a problem called flocculation. The wrong additive can cause all sorts of surface defects. And if the solvent doesn't evaporate right, it gets trapped inside, creating a weak point. Literally any of these could be the root cause of a pinhole.
And we're not talking about just simple mixing. This is really advanced chemistry. Formulations use these complex principles to basically create invisible force fields around every single pigment particle, just to stop them from clumping together. It's this incredibly delicate, microscopic balancing act that is so easy to get wrong. Okay, so let's just say your formulation is absolutely perfect. You're still only halfway there. Now you have to get that liquid onto a surface and turn it into a durable, solid film. And this is where a whole new world of problems can pop up.
Here's the thing you have to remember. The surface you're coating is an active participant in this whole process. A single fingerprint, seriously, with its oils and salts, can create an invisible barrier that leads to total adhesion failure. And the material itself matters. Wood, metal, plastic, they all dictate how the coating is going to behave. This is exactly why pretreatment is so often a non-negotiable, critical step. Now, this four-step process looks pretty simple on paper, right? But each stage is like a minefield of potential errors. A mistake in prep can doom the primer. A flaw in the primer messes up the top coat, and a problem in the final cure can ruin all the hard work that came before it. It's a total chain reaction of potential failure.
And you can forget about just a simple spray gun. Modern manufacturing uses these incredibly advanced techniques. We're talking everything from thermal spraying to chemical vapor deposition. Each method has its own unique physics, its own chemistry, and introduces dozens of new variables that have to be perfectly controlled.
This brings us to the huge gap between the lab and the factory floor. I mean, in theory, every condition is perfect. But in the real world, you've got temperature swings, airborne dust, production quotas forcing people to rush. You even have mismatches in how the coating and the substrate expand with heat. This is where most defects are born. And finally, curing. Now, this is so much more than just letting the paint dry. It's a chemical reaction. It's a transformation from a liquid to a solid. If it's underbaked, that film never gets its full strength. If the temperature is off, thermal stress can create tiny microcracks that become the seeds for future failure. So, with all of this complexity, how in the world do you actually solve the problem? How do you trace that one tiny pinhole all the way back to its original source? And this really gets to the heart of the challenge, doesn't it? One single pinhole could be caused by an issue in the formula, some contamination during prep, a problem with the application, or an error in the cure. It's a true needle in a haystack situation. Look, chasing symptoms is a losing game. Just trying a new additive or tweaking the spray gun settings, that's just guesswork.
The only way to solve this problem for good is to find the one root cause that is affecting your unique process.
The answer is a holistic, systematic analysis. It means looking at absolutely everything, from the moment the raw materials show up at your facility to the moment that final product is cured and inspected. It takes deep expertise in chemistry, in materials science, and in process engineering.
So if you're tired of chasing defects and you want a permanent solution, that kind of deep analysis is exactly what you need. Finding the true root cause means you need a partner with expertise across the entire process. For a complete, systematic analysis of your coatings line, from the formulation to the final cure, including consultation and on-site support, just reach out using the email on your screen. Stop treating the symptoms and let's solve the root cause together.